Good morning, Bears. Let's get this started. All right, Bears, let's do this. It is a Monday. It is a science week. We are in 1 through 4 in our classes today. So that means we'll be in 1 through 4 again tomorrow. And we are diving into metabolism of elite athletes. Very exciting. So I don't know if you noticed, but when I did I'm borderline an elite athlete. My blood pressure or my breathing rate is only about 60 beats a minute, and for athletes it's usually around 40 to 60, so I'm right there in the athletic range. Kids, it tends to be a little higher, so don't worry if yours is higher. But why that is your heart is in such good shape that it doesn't take as much work to beat, so it's nice and gently. So every beat, plenty of blood comes through, so it's not working hard to get your body circulating, and that affects your breathing and your blood pressure and the heart rate. Monday morning, we're just getting started. So today we're diving into that. If you remember, we left Elisa. We solved her problems. She had diabetes, lack of energy from not processing glucose correctly. So we're leaving Elisa, and we have a new message coming in from our doctor. Let's go check it out. You can find your lesson in science over to the right. Notice it says Amplify, week number 4, Metabolism. We can go to our groups to get the lesson in basics and the video and the links on the article we're going to read right now. And we'll read it here together in the video. Then you will discuss it in your breakout rooms, and then we'll do a slide. And we have a pretty fun bonus top slide to do today. So Science Week, Monday, period 1 through 4, Metabolism of Elite Athletes. Basics, read article and annotate, that means highlight, and make comments. 5 citations that interest you. Slide 10-ish. Why do I say 10-ish? Because some of you add slides. We do different things, so it might not be exactly 10. You will see it right now in the video. Click link at the bottom of the slide. Now I also have a link here that should work. Now you're going to need to sign in with your Google. And if it doesn't work, you have glitches, that's okay. Just watch this video where you're watching now. Pay attention as we read. Pause it. Pick 5 areas of interest. And then you won't be able to copy and paste from a video, but then you can just write notes about it. So if glitches, just follow along with my video post and write 5 notes on your top slide like we always do. And I'll demonstrate that in a minute. So your main assignment today, copy and paste 3 of your annotations in the article, if the copy and pasting works, and paste into top slide. Write why you picked that citation, and that's going to be 1 to 2 sentences. Now, if article does not work and you're just going from the video, go ahead and write 2 to 3 sentences about 3 areas of interest, and you don't have to copy and paste. And then make a montage, here's your bonus, of your favorite athlete in your top slide. In the title slide, you can make it the title slide, and if you really want to go, you can actually make a whole new slide about it, up to you. But if you want just your title slide, because we're studying elite athletes, you can have 1 athlete, you can do multiple athletes, just find cool pictures about your favorite athletes. It's going to be fantastic. All right, let's go down here. Once again, we're in science. Some of you who are getting D's, today is the day. Go in, open it up. Now, once you're in, you need to probably click My Document or something like that. Edit document. Always try to open it outside of the range of being in Schoology, because it's much easier to work and edit with. So let's get started here. Notice, use title to create montage of your favorite athletes. Metabolism, week number 4, lesson 11 through 14. Let's get through this and get to our article. Dr. Walker has sent us another message. Let's read his email on the next slide. Thank you for wrapping up the diagnosis. I'm going to go to present mode. Thank you for wrapping up the diagnosis of Elisa. Thanks for your careful investigation. We've been able to get started with a course of treatment that should have Elisa feeling more energetic soon. We have a new assignment for you now. We want you to learn about the metabolism of athletes. Not just any athletes, but world-class athletes that train for many hours every day. Energy release in the cells is very important to these athletes. Today you will read an article to start thinking about the energy needs of these athletes. We started learning about metabolism by investigating several medical conditions in which things were going wrong with metabolism. Now we will examine the other end of the spectrum. We will consider how elite athletes are able to increase their cellular respiration in order to compete at the highest levels. Remember, we kind of did some of that with the deep breathing. It's going to tie into this. Superheroes. We'll be reading on an article about blood doping, a way in which some athletes have tried to trick their bodies into having just a bit more energy than they would normally have. This process is illegal, but some athletes do it anyway. The article will explain what blood doping is and how it can provide an athlete with more energy. The following slides show how a 6th grade student named Jai made annotations on a digital version of the blood doping article. You will see what Jai was thinking about when she was reading. You will also see each annotation that she made. These slides will show you how to annotate to show your thinking. We already know how to do that. Some strategies you can use, such as asking questions and making connections. And here's our guidelines. Think carefully when you read. Pay attention to your own understanding. As you read, annotate the text to make a record of your thinking. Highlight challenging words and add notes to record questions and make connections to your own experience. These we will put in our slideshow, so make sure you do this. Examine all visual representations carefully. Consider how they go together with the text. After you read, discuss what you have read with others to help you better understand the text. Now, these are all things we have become really good at because in our history, we make our own slides, we do research on the internet, we find our stuff. So you guys are great at all of this. You can follow along in your article as you see what Jai did with her annotations on the next slides. You can also add your own annotations as you follow along. So let's read the article. Remember, this link is in groups. Read along with the read along now, and then we will talk about the annotation. Now, if you can open this, and if you'd like to read along with the audio on your own, you may start doing your annotations. Now, let's take a look what we mean when we talk about annotations. Remember, you're going to have to log in. Make sure you log in with your school account. And let's see here, blood doping, there it is, teacher support. Where's my article? Let's go find it. I guess it's right here. Here we go. Yours may open up a little differently, and hopefully you'll be able to look at it. Like I said, if for some reason your links don't work, just follow along with this video, and you can write your own notes by pausing the video later. But hopefully it works. Reading like this, a lot of times the first time you read something, if it's short enough, you just want to read it first. Don't worry about annotations, but maybe take some notes. But if you really see something interesting, you can annotate on that first read. So if you're advanced and you can pull that off right now, fine. But basically for most of you, just listen along. Let's read the article. Then we'll come back and annotate one together. Here we go.
Blood doping. Messing with metabolism to win races. To win international bicycle races, you can't just be in good physical shape. You have to be in amazing shape. Your metabolism has to work like a well-oiled machine. The world's top cyclists work to perfect their muscles and body systems so that they process oxygen, glucose, and amino acids better than almost any other humans on Earth.
Notice, referring back to the stuff we have studied, it's always good to take a look at a picture. I mean, it's fun. Where are these guys at? You can look at their muscles. You can see how strong they are. It's intense. The world of international bicycle racing can be so competitive that some athletes cheat by blood doping. We do not want to cheat. But we can learn about the article just by reading that. So always check your pictures. Remember, you can make any athlete you want. Basketball, volleyball, swimmer, anything you want for your top slides. Does not have to be biking. Let's get back to the article.
A cyclist's metabolism. What's so special about a top cyclist's metabolism? Cyclists' muscle cells contain unusually high numbers of mitochondria, where glucose and oxygen combine to release energy. That means their muscles can release more energy than most people's muscles. To bring in more oxygen, top cyclists breathe hard, up to 75 breaths per minute. To bring in more glucose, they eat lots of carbohydrates, such as starch, even while they're riding. Cyclists often slurp down special gels filled with glucose while they're on their bikes, one hand on the handlebars and the other popping open the gel. To transport these molecules more quickly to their muscle cells, their heart beats fast, up to 200 beats per minute. A faster heart rate pushes the molecules through the circulatory system more quickly and out to all the cells in the body sooner. The problem for top cyclists is that even all that isn't always enough to win. Every cyclist in the race is in perfect physical shape, and all of them are looking for an edge to help them win. Sadly, that means some decide to break the rules to help them get ahead, not by taking a shortcut on the race course or breaking a competitor's bike, but by injecting themselves with extra blood from their own bodies, a practice known as blood doping. Blood doping is banned, meaning it's not allowed in competition, but some cyclists secretly do it to improve their performance. The most famous example of an athlete who used blood doping is Lance Armstrong, who was known as the best cyclist in the world until he admitted to blood doping in 2013. What is blood doping? In most cases of blood doping, an athlete drains some of his or her own blood, chills the blood to keep it fresh, and stores it for several weeks or even months. The athlete's body naturally works to replace the lost red blood cells. Then, just before a competition, the athlete injects the stored blood back into his or her body. Injecting blood increases the number of red blood cells in the athlete's body. How blood doping works in the body. Red blood cells carry oxygen from your lungs to every cell in your body.
Let's pause for a second, take a look at our pictures. You can use your pictures for your annotations or notes. They drain the blood, they store the blood, and then they put it back in, so you're getting like a double dose of that oxygen. And there's a little note on that. You can learn a lot from your pictures. Here we go.
Including your muscle cells. The red blood cells fill up with oxygen in the lungs and then are pumped out to the body cells, where they drop off the oxygen before returning to the lungs. Each red blood cell can only carry a certain amount of oxygen. Once your red blood cells are full, you can't get any more oxygen into your blood with that breath, no matter how much air you take in. Blood doping improves the body's ability to carry oxygen by increasing the number of red blood cells in the circulatory system. With more red blood cells, the circulatory system can deliver more oxygen to all the cells of the body. The extra oxygen delivered to the body's cells can increase the rate of cellular respiration, which can help an athlete perform better and for a longer time without becoming tired. This happens because oxygen is necessary for the release of energy in the body. The body's cells release energy through a chemical reaction called cellular respiration. For cellular respiration,
Take a look at here. We've got our blood vessels, normal blood, dope blood. Obviously, more blood cells means more oxygen. We've learned about this already. Great job.
to happen, cells need both oxygen and glucose. Oxygen enters the body through the respiratory system and is delivered to all the cells of the body by the circulatory system. At the same time, the circulatory system provides the cells with glucose produced when the digestive system breaks down food into starch. Inside the cells, the glucose and oxygen react to produce carbon dioxide and water and release energy for the body in the process. More oxygen in the body means a faster rate of cellular respiration and increased release of energy. Catching blood dopers. Blood doping is very difficult.
Once again, a reference back. Remember, our mitochondria, oxygen goes in, glucose goes in, carbon dioxide goes out. Remember, we tied into that with our Egypt pyramids. Too much carbon dioxide, if you're in a tight space, and it can kill you, so you've got to get it out into the air. Water goes out, and mitochondria also creates energy. Oh yeah, here we go.
To detect. Since the body always contains red blood cells, it is difficult to find evidence that an athlete has injected extra red blood cells into his or her bloodstream. One detection method involves testing the age of the red blood cells in a blood sample. The human body constantly produces new red blood cells to replace cells that have died. Blood doping means injecting stored blood, and the red blood cells in stored blood are older than the new red blood cells constantly being produced in the body. A blood sample with an unusually high number of older red blood cells can be evidence of blood doping. Another method scientists use to detect blood doping is testing the amount of hemoglobin in the athlete's blood. Hemoglobin is a protein made by the body that carries oxygen in red blood cells. The more red blood cells a person has, the more hemoglobin you'll find in his or her blood. Athlete has a hemoglobin level that is higher on the day of a race than it was a week before the race. That provides evidence that the athlete might be blood doping. The athlete might even be disqualified from the race if his or her hemoglobin levels are too high. Dangerous side effects. One serious potential side effect of blood doping is that increasing the number of red blood cells also increases the thickness of the blood. This unusually thick blood makes the heart work harder and can even cause heart failure, an alternative to blood doping. There is a legal way for athletes to increase the number of red blood cells in the body: high-altitude training. In the weeks leading up to a competition, some athletes train in the mountains. At high altitude, there is less oxygen in the air than at sea level. The athlete's body adjusts to the lack of oxygen by producing more red blood cells. Because the body senses that less oxygen is available, it produces more red blood cells so that more oxygen can be picked up with each breath. It takes the body several weeks to adjust and increase the number of red blood cells. High-altitude training takes a longer time than blood doping, but it has the same effect and is not considered cheating. However, high-altitude training may have the same harmful side effect of making blood thicker.
So high altitude training has similar effects to blood doping, but it is legal. And there you have a picture of somebody training in the mountains. Fantastic. All right, so I'm going to do one quick example of what you need to do. Then I'm going to give you some time here to log in, make sure your article works, hopefully, and we'll get and then I'll have you guys highlight, annotate, and then we're going to discuss it, and then you can create your slide and your bonus slide. So remember, when you annotate, this is a great little app here, and don't forget it keeps track of your stuff. So this little annotation button, that annotation button shows things you've done, and let's get rid of that. We don't care about it. So let's just talk about metabolism, say that interests you. Remember, I just want some science-based things that just interest you. You're not looking for a claim, it's just something fun. So top cyclists, metabolized cyclist muscle cells contain unusually high numbers of mitochondria. That's pretty interesting to me. So we come down here and we highlight it. Now notice you can highlight, and then you can also make a note about it. So let's do that again. Let's highlight it. I should have done that before. Whoops, sorry. I think because I clicked that, now I have to close it. There we go. So let's highlight that again. Hello. Why is it not highlighting? Let's highlight that again. My goodness. There we go. You have to double click. So highlight that again. And then you can make a note. Now you can make your note here and then copy and paste it if you want. I want to know more about how they have more mitochondria. So you can do a question or a note, or I find this interesting because I want to be an athlete, anything like that. Now, if you save this, this will save. But what we're going to do, I want you to just do 5 of these right now. You do not have to do the note part if you don't want. But that might help you because then later you can copy and paste it to your slide. And also you can read that note to your breakout groups. So right now, let's everybody go into your slideshows. Make sure you do 5 highlights, spread it out through the article. You can do one of these, and then be ready to share about one of them in our breakout group. So 5 highlights, 5 minutes. Let's do this. Everybody should have 5 highlights in here. You might have some notes, maybe you don't. See, I highlighted, there's my note that I wrote. If you have that note, it's easy now because now you can just read that note to your breakout group. So everybody should have 5. If you have only 1, well, that's the one you're going to read. If you have 5, be thinking about which one you're going to share. All right, let's go into our breakout groups. I want you to kind of direct people where in the article you're at. So for example, you might say, oh, I'm in the 2nd paragraph of the article. Or you might say, scroll down to where it says, what is blood doping? I'm in the 1st paragraph. Or you might go down, oh, I'm in the picture with the arms. Or you might say, oh, if you scroll down, I'm to the title that says catching blood dopers, but I'm in the 2nd paragraph. So direct people where you're at so they can scroll in the article with you and read what you're going to talk about. Now, say you did this one here, here's oxygen to red blood cells, and you had your note, I learned that oxygen is carried in the blood last science week. So you're just making a comment or a note, and you save it. And now you come down and you go, oh, I'm in the second paragraph after catching blood dopers, and I'm focused on the third sentence. Then you read your sentence, made by the body that carries oxygen in red blood cells. And if you took a note, then you read your note, okay? And then you do that just for one and let the next person go. All right, let's go into breakout rooms now. Make sure you have something to read and something to say about it in your breakout room. Let's go in there. We have 4 people, 3 to 4 people in the breakout room. Probably talk for 30 seconds. Let's not mess around. Let's get in there and just read your note. Let's go a minute each. So I'll give you 5 minutes. Now you may say hello first, talk about your weekend just a little bit if you want, and then share. So go one round robin, say something fun you did for the weekend, or you can say your favorite athlete. Let's do that. Let's say your favorite athlete, then go around the room. Everybody says their favorite athlete, and then talk about your note, your citation, and your note and your annotation. All right, let's do this. 5 minutes in the breakout rooms. If you're in Zoom with us, we'll share out in the class. But if you're just watching this video at home, I'll just share one for you. So for example, say I highlighted blood doping in blood cells. And I say, I thought this was interesting. It seems weird that you could actually have more red blood cells in the blood like this. And that does seem like it would be dangerous. That's kind of what I learned from this picture. So there's my citation. It's a visual. I explained what I learned from it, and I'm done. Now, what's the next phase? Let's all go back and say, I took this one. I need to go back and copy again. Man, I don't know why. It's a little trickier than I'd like it to be, I tell you that much. Anyway, I don't know, you guys. You're going to have to play with this. You're better at this than me, probably. There it is. So I'm going to come back in here. Now watch this. I'm going to copy this, bring this into my Amplify slideshow, escape, and then I can bring that all the way up, make a new top slide, and I'm going to start putting my notes in. Remember, this is your bonus montage of your favorite athletes. Now let's continue on down here first after our article. And I will show you that I already made you a slide for that copy and paste. So let's get to this part. All right, let's see. What is going on here? There we go. Oh boy, this is not gonna work. Get back in there. So Jai has his comments. You can read those on your own. Jai recorded her questions about this section title so she could come back to it later. I taught you how to do all that, so we can skip that. We did the reading. We've annotated. These slides just talk about that if you need it. We've done our partner work. And then we discussed our annotations and our thing. And then here we go. This is the slide we're going to move to the top. Copy and paste 3 citations from your highlights and write why you picked this for the topic. So here's where I would paste in my citation. Boom. And then I would write why I picked that. If you already wrote that in your notes, you can go copy that as well. And so your work is done. Create this slide, organize it, and move it to the top of the slideshow. So I'm going to delete this because otherwise it's going to be in everybody's slide. So move that to the top. Mandy's today are favorite athlete or athletes in your title slide. Copy 3 citations from the article into this slide, move it to the top, and then write why you picked that citation from the article. Probably all we can get through on today. It's a Monday. It's elite athletes and how their metabolism works. Let's dive in, get it done. Pictures of your athletes on the top, 3 citations from the article in this slide, and then you make a note why you picked that citation. Let's do this. Can't wait for tomorrow to see what we're going to learn about elite athletes.